4, in which we learn how to graph or solve systems of linear inequalities. Okay, so we only looked at one problem, so I'm going to choose another problem now. Let's say 23 on page 578, in which we have 4x plus y less than 8. So the question states, graph each inequality. This is the only way to solve such an inequality, by simply graphing it. But there are a few steps that I have to follow. So I'm asked to graph the inequality, and I'll put in parentheses. This is the only way to solve it. In order to solve it, I have to graph it. Here's the first step. I have to write the corresponding equation. And you can say, why are you changing the inequality into an equation? I'm not. I have to graph this line first. So in order to graph this, graph the line, I need 2 points. When x is 0, I cover it, and I determine y, how much. So the ordered pair is? Very good. Now when y is 0, I cover that, and I get that x is 2. So then the ordered pair is 2, 0. So I would graph this line, plotting 0, 8 and 2, 0. So 0, 8, 1, 2, 3, 4, 5, 6, 7, 8, and 2, 0. So this point and this point. However, before I graph the line and extend it, I have to look at the inequality symbol. Since the inequality symbol does not have the equal symbol, I cannot graph the line as a solid line. Dotted line or dashed line, whatever you want to say. So this is 4x plus y equals 8. So in the first step, I write the equation and I graph the equation using the x and y intercepts. In the second step, I will pick 0, 0 if the line does not pass through it. If it passes through 0, 0, you cannot choose a checkpoint like 0, 0 in this case. So notice that 0, 0, or the origin, is on the left-hand side of the graph of the line, right here. So this is the region I'm checking. So I go back to the original problem. Here's the original problem, 4x plus y less than 8, and replace x and y by 0. What do I get? Can anyone read the statement we get? 0, 0, 0 less than 8. Is this a true statement?
Yes.
Therefore, I have to shade in all the region that has that point that I checked with. If it were a false statement, but it's true. If it were a false statement, I would have chosen the opposite territory. Inside this territory, I must write 4x plus y less than 8 anywhere you want. And this is the solution. Some students write this. Please do not do that. On the line, instead of writing the equation, they write 4x plus y less than 8. I cannot give credit for that. This is not the line, the equation, the inequality. This is the line. So please do not do that. So that's why we have 3 steps. In the first step, I graph the equation, and I write that I graph the equation. I write the name next to it, left, right, anywhere, or pointing to it. So this is the equation. Then I use a point, and I like to use 0, 0 because it's very convenient. I don't have to calculate anything. But if the line passes through the origin, then you have to pick a point like, let's say, I don't know, 4 comma 4 in this case. The line doesn't pass through the origin, so I use the convenient point. But let's look at an example in which the line passes through the origin. So here's an example. Any questions for me before we continue? Yes, please, Daryl.
So you want us to write 4x plus y equals 8?
Next to the line, yes. Or the solid line, if it's solid.
And then for the
after you solve and you shade in anywhere you want, here, or here, whatever you want, but you have to write the inequality.
And the shaded in there.
Yes, because that is the solution. I have no other way of graphing this. So in other words, I'm telling you this. This point, let's say -4, -6, will solve the inequality, and I guarantee you it will. I'm telling you that this point, -10, 0, will solve the inequality, and I guarantee you it will. I'm also telling you that this point, 4 comma 4, does not solve the inequality. 16 plus 4 is 18, which is not less than 8. Yes, please.
So we found solve the equation, and we're about to shading in.
That's the inequality, not the equation.
We're trying to shade in the inequality.
Right.
Whatever the number is, like it's 8. If it's less than 8, then we shade below the line.
If it's a true statement, whatever you get. But if you get 0 greater than 8, you cannot shade this because it will be false. So you have to shade the opposite.
Yeah, that's what I mean.
Yes, whatever you get. If you get 2 less than 5 or 0 less than 8, then you know that this is a true statement. So you shade in the area of the point you used to verify. Yeah. So I'm going to give an example right now with a line that passes to the origin. Let's see what we do then. So the first step, as we know, is to write the equation y equals 2/3 x. And I have to find 2 points. I need 2 points. Well, of course, when x is 0, how much is y? Right. So I picked the equation, the inequality in such a way that it passes through the origin. So I have to find another x because 1 point is not good enough. And pick an x that makes y very easy to calculate. Because you can pick 7, but then you'll get stuck with 14/3. Yes, that is the best. So if x is 3, how much is y? 2/3 times 3/1. You simplify the 3, and you get y equals 2. So the other ordered pair is? Very good, 3 comma 2. So now I'm ready to graph. I will plot 0, 0, and I will plot 3, comma 2. Now I stop for a moment and I look at the inequality symbol. What would you advise me to do? Would you advise me to graph a solid line? Very good. They're all straight, but this is solid. Right. I agree. Please write on the line y equals 2/3 x. This is not the inequality. Now, since the line passes through the origin, I cannot use the origin. I have to pick a point anywhere you want, but you have to remember where you picked it from. That's all. Let's say I want to pick this point. Give me the coordinates of that point, please. Very good. Excellent. So, x is 0 and y is 10. What is the statement that we determine? What is the statement that we get when we replace y by 10 and x by 0? 10. Is this a true statement? No, it's a false statement, so I cannot shade in the area that has that point. So I have to shade in the opposite. And this is where I write y less than or equal to 2/3 x. All the orange region, including points on the line. Here, the points on the line were not included. They were not part of the solution. So these points are not part of the solution. These points are part of the solution. For example, 0, 0 will be a solution. 0, 0 is 0 less than or equal to 0. Yes, this is a true statement. So that's why now, because of the equal symbol, all points here are part of the solution. Now, what do we do with this? You can say, okay, this is beautiful. So what? Okay, here's what we do with this. Although it's not part of this course, we are preparing for the next course. So what we are trying to do is solve different situations in which we have several conditions, several restrictions or conditions that have to be fulfilled. And that is called a system of inequalities. However, the application was removed from this course. So the application of what we're doing right now has to wait for the next course. But I still have to work on systems. So on same page, 578, I'm going to choose a system. And let's start with 49. Page one more time, 578. So y greater than or equal to x plus 1, and y greater than or equal to 3 minus x. So now we no longer have one condition, one inequality, but two. So what is the idea now? Here I'm asked to find the region that verifies both inequalities now. That verifies both, there's nothing else, it's just H, inequalities. So I need now to find the region that verifies both inequalities at the same time, of course. I have to go through the following steps. The first inequality, step 1, 2, 3. The second inequality, step 1, 2, 3. And then intersect the areas or the regions. Ready? So step 1, y equals x plus 1. When x is 0, how much is y? And the ordered pair is? Perfect. When y is 0, you have to move 1. Negative 1. And the ordered pair is? Negative 1, 0. Perfect. So now let's graph. So I plot those 2 points, 0, 1, and 0, negative 1. And now I stop and look. And can you please identify whether I have to graph a solid line or a dotted line? Solid, because the equal symbol here. Correct. So I graph and extend a line. Please write somewhere on top of it or below it y equals x plus 1. We did not graph the inequality yet. Since the line does not pass through the origin, and the origin is in the bottom territory, I pick the origin and I say 0, 0. What statement do I get when I replace x and y by 0 in the first inequality? Yes, I get that 0 is greater than or equal to 1. What do you think about this statement? Is it true or false? False. So that means that I cannot shade in this area. I have to shade in this area, which represents y greater than or equal to x plus 1. I will repeat the same 3 steps for y equals 3 minus x. Y equals 3 minus x. When x is 0, how much is y? Very good. So then 0, 3. And now when y is 0, remember you have to move negative x to the other side. So x is 3. So 3 comma 0. Do we all agree with these two ordered pairs? 0, 3 and 3, 0. Is that a yes?
Yes.
Okay. Thank you. So then I have 1, 2, 3. And this was 1, 2, 3. I have to stop and look at the inequality symbol. Does it have the equal symbol? Okay, which means I have to draw a solid line. On the line, I will write y equals 3 minus x. Agreed so far? The blue line does not pass through the origin. I will pick the origin to check this area. So I go back to the original 0, 0. Is 0 greater than or equal to 3? No, which means I cannot shade in the region with the origin, but the opposite. The blue region becomes solutions to y greater than or equal to 3 minus x. Now I have two regions. I have a brown territory here, and I have a blue territory here. I have to choose that region that consists of or has ordered pairs that will verify both inequalities at the same time. If I choose this area, no inequality is true. If I choose this area, only the first one is true. If I choose this area, only the second one is true. So where do I look? Where they're both shaded, where I see both colors. This line, this corner, this line, and everything in between. That is the solution of the system. So if you have two constraints, you open your own business, and you have limited resources, you have limited number of people, you have limited number of or capacity for production. These are your constraints. You graph the constraints, you get the region, and then that's where you find the maximum and the minimum for a function. But we don't no longer do this in this class. We moved it to the next. Any questions about how to solve or graph a system of two linear inequalities in two variables? We will choose more examples in a minute. Any questions on this problem first? Are we okay? Okay, good. So now I would like to choose, let's say, 70 on the same page, 578. 2x plus 5y less than or equal to negative 10, y greater than or equal to 1. Let's work on this for a minute. Graph the equation. Pick a point. Shade the area. Graph the equation. And there is no need for a point for the second one. Just graph the area. 1 minute. Please remember to write the equation on the line, not the inequality. If you need help, let me know. I will post your next homework that is due next Wednesday.
So our homework's gonna be due on Mondays, or I'm sorry, on Wednesdays from here on out.
Always on Wednesdays, unless we have a test on a Monday, and I have a little remainder of a little homework to turn in. But it would, yeah, what we cover this week will be due next Wednesday.
Like today, there's no homework.
Right. Yes. Yeah, you can use any of this. You choose. Do we need more time? Okay. Okay, ready? So first I have to write the equation, which is 2x plus 5y equals negative 10. Then I make x equals 0. I cover it. I know this is not scientific or mathematical, but this is really what we are doing. So y equals negative 2. So the ordered pair is 0, negative 2. Now, when y is 0, please cover that term and tell me x. So it's negative 5, 0. Do we all agree? Okay, so I will graph a line going through these 2 points. This is 3, this is 4. Yes, please.
Do we, just because I did it this way, not thinking, what if we got y by itself and then just graph that? Is that okay, or you want us to do the x and y?
It's fine. You are working 2 minutes more than we should.
Yeah, I just happened to do it, so I was wondering.
You need the x and y intercepts. So solving for y will not help in any way. It will just make your life more difficult because you'll have a fraction in there.
That's the same points.
Right. It's work that doesn't need to be done.
So
And in certain inequalities will make your life more difficult. Okay, so then we have negative 5, 0, and 0, negative 2. I stop and I look at the inequality symbol. I see they're both have equal symbols. So I'm just going to graph the line. I write 2x plus 5y equals negative 10. I will definitely check with the easiest possible point to work with. 0, 0. I got that 0 is less than or equal to negative 10, which is a false statement. Therefore, I cannot shade in this. I have to shade in the opposite. So the opposite is 2x plus 5y less than or equal to negative 10. It happens that the second one has only one variable, so I only need to plot y equals 1. How do I plot y equals 1? What type of line is that? Right. So it's a solid line also because of the equal symbol. So I graph y equals 1. And now I'm asked to graph the area that has whatever x you want, but the y value is 1 or more. I see that this is a line that divides the entire plane in 2 regions, top and bottom. Which of these 2 regions will have whatever x you want, but y that is greater than or equal to 1? Y greater than or equal to 1. And everything below is going to be below 1.
Also like 2.
1 or above, of course. Yes. So this is y greater than or equal to 1. Now again, I have 2 colors in there. I have brown and orange. I need to determine the area that verifies both inequalities at the same time. Is there one? Yes. Everything on this line, this corner, everything on this line, and everything in between. This is the solution to both. And I should write it. an arrow in here pointing inside the green area? Both. Solutions to both inequalities. So if I want to find points that verify both inequalities at the same time, I have to pick from the green territory or region. No other ordered pair will verify both inequalities at the same time. This completes chapter 9, and I would like to review it now. So if you have your books, please open on page 582, 583, anything from 1 through 52. If in the next couple of days you do all these problems, so 1 through 52 from chapter 9, and you check the answers in the back, and you get them all correctly, you can teach chapter 9. Because I will not invent anything. There is nothing else but what you see between 1 and 52. So if you do that for the next couple of days, next week you can come in here and you can teach us chapter 9. And if you do this a little bit every weekend from now on till the end of the semester, you will never forget chapter 9, ever. Okay, so please choose. Please.
Is the homework on chapter 9 too?
The homework on chapter 9 will be due next Wednesday. I did not even post it yet. I didn't even pick problems or look at it at all. Okay, are we going to choose?
3.
Which one?
3.
30?
3.
Oh, 3. Very good. So this was your problem on the test. I just changed it a little bit. Because this is part of 9.1. So 9.1 was part of the test. Actually, I should have mentioned 9.2 through 9.4 will be part of the next test. But it's good. Okay. So how do we address this?
The 3.
Find the smallest 2 involved.
Do you think the lamp is dying on this, or are my eyes not good? Okay, so 6, 3, and 5. The least common denominator is, so yes, it is 30. So we have to multiply everything by 30 over 1. So 30 over 1, 30 over 1, 30 over 1. The left-hand side, please.
5.
Very good. Less than. So I have to simplify 3 by 3 and 30 by 3. So it's 10, 4x minus 3, less than or equal to
40x minus 30.
Yes, in a moment we'll do that, yes. Of course, now we have to distribute. So 5 less than
40x minus 3.
less than or equal to 24. What do we need to get rid of first?
And 30.
Yes, we have to add 30 to all 3 sides. So then 35, 40x, and 54. And divide all 3 sides by 40 and try to simplify as much as possible. So 35 over 40 less than x. Oops, is less than or equal to 54 over 40. So 35 and 40 by 5. So 7/8 less than x, less than or equal to. And here, can I simplify by 4? No, just by 2. 27 and 20. In interval notation, 7/8 comma 27 over 20. Okay, good review. But we are really interested in 9.2, 9.3, and 9.4.
Well, 36.
36, let's take a look. 36, very good. 36 on page 582. Any questions before we look at 36?
You know how you know how you were like 30 over 1? Can't you I don't know how to explain this how I was taught in high school, but you multiply like the numerator like individually, you multiply like you would, for the middle one you'd be like 3 times 10 and multiply the numerator by 10 for it all to be the denominator of 30. You get what I'm saying?
You don't want to make the denominator 30. You want to eliminate the denominator.
Yeah, but then when they're all 30, you can cross them all out.
Very good question. So
Do you get what I'm saying?
I think so. I think so. Let's take a look. So 1/6 less than 4x minus 3 over 3 less than or equal to 4 over 5. So what would you do?
Oh, yeah. I would, like, I'm not explaining, like, I'd multiply each thing by how many it takes. Like, I'm terrible at math, but, like, for example, the middle one, you'd say 30 times 10, because, 3 times 10, which you could see to 30, and then you do the same thing for this. I don't know how to explain those.
It's the same thing then.
Yeah, that's what I'm saying.
It's the same thing.
Yeah.
But you're making it more hard. What is that,
Maybe
right?
if I get it that way, but I was wondering if we can still use it.
She's saying if you multiply 6 times 5, 3 times 10, and 5 times 6.
And then I'll get
Instead
30
of
and
30
cross
over
out the whole.
Right, but do you understand that we are not multiplying the left-hand side by something, the middle by something else,
No.
and the right by something else?
Yeah.
We're multiplying both sides by 30.
Yeah.
All 3 sides, I should say, by 30. And this is what happens. You simplify. Because you will simplify 30 and 3 by 3, and you get the 10 in front. So,
It's literally the same exact thing.
okay,
I'm just
then
saying
yes.
allow that on the test if I didn't write like 30 over 1.
Yeah, that's fine. As long as you get to this step, I'm fine. Of course, yes, of course. Okay, 36 on page 582. 36. So we have y less than or equal to negative 3x plus 3, and y less than or equal to 2x plus 7. First, the equation. Y equals negative 3x plus 3. When x is 0, y is? Very good. So then 0, 3. When y is 0, remember it's 0, you have to move negative 3x to the other side.
-1.
It will be positive 3x, right? Because I move it. So 3x, exactly. So 1 comma 0. So I can graph the first line. So 1 comma 0 and 0 comma 3. I stopped for a moment and looked at the inequality symbol. Since it has the equal symbol, I know I will have to graph it as a solid line. Yes?
You wrote the original wrong. It's negative 3x minus 3.
Oh. I do that a lot.
Can we just leave it?
Should we just change it to as additions
Wait.
Once I change this, I have to change the whole thing. That's fine. That's fine. I don't have a problem with that.
Paper is precious.
So we continue with this?
Yes.
Okay.
It's very like no problem.
Okay. And then we can do the other one, of course. Sorry about that. Sorry. So this is no longer 36. It's just something we made up. Okay. I choose the origin. 0, 0. Is 0 less than or equal to 3?
Yes.
Okay. Which means I have to shade in the area with the origin in it. And this is y less than or equal to negative 3x plus 3. And that's the green territory. Now the other one is y equals 2x plus 7. When x is 0, y is,
7.
so 0 comma 7. And when y is 0, I move 7 to the other side, so it's going to be negative 3.5. So negative 3.5 comma 0. Okay. 1, 2, 3.5. And 7. 3, 4, 5, 6, 7. This is a solid line. I write on the red line y equals 2x plus 7. I pick the origin, and I get that 0 is less than or equal to 7, which is a true statement. So the area with the origin has to be shaded. And this is y less than or equal to 2x plus 7. And now I'm looking at the green region and red region, and what do I do with that, with those two? We intersect them. So it's this point, this line, the corner point, this line, and everything in between. What is this? Both at the same time. So only the green region has solutions, ordered pairs, that verify both inequalities at the same time. Is this okay? Anything else you would like to choose from 7 through 40? I would like to practice at least one more example from the two types of inequalities with absolute value and one from the equations.
Are we going to do 36?
Which one?
So are we going to do
Okay, let's do 36 now. Any questions? Okay. Y less than or equal to negative 3x minus 3 less than or equal to 2x plus 7. So this is indeed 36. Y equals negative 3x minus 3. When x is 0, y is negative 3. So 0, negative 3. When y is 0, x is negative 1. So negative 1, 0. Do you agree so far? Yes or no?
Yes.
Okay, so then the green region will be given by 0, negative 3, and negative 1, 0, and it's a solid line. And I write on it somewhere y equals negative 3x minus 3, so I know what I graphed. I pick the origin, 0 less than or equal to negative 3, and the answer is false. 0 is not less than or equal to negative 3, so I cannot choose this. I have to choose this. And this is y less than or equal to negative 3x minus 3. And now the other one, I just copy it because there is no change there. So from the previous example, the red line still goes through 0, 7. And this is 1, 2, 3 right here. 1, 2, 3, 4, 5, 6, 7. It's the same line. There is no change there. So then y equals 2x plus 7. The same shaded area, 0, 0. 0 is less than or equal to 7, so it goes in the same direction. And there goes my red. Ah, done. Have another one though. So this is y less than or equal to 2x plus 7. So I have again a green territory and a red territory, and they overlap here. That corner, this line, and everything in between. Okay, any questions? Any questions? (27) x over 3 plus 6 in absolute value minus 8 greater than negative 5. Let's take 1 minute on this. and 1 minute on an absolute value equation, and 1 on an absolute value inequality, another one. So after this, I would like to look at 48, and I would like to look at 15. And then I'd like to start chapter 10. Anyone tell us what to write?
You add the 8,
Yes?
so you get x plus 6 is greater than 30.
Good. And now I have to establish which of the two inequalities we are looking at.
The harder one.
The harder one, which means that it separates into two different inequalities, and it has to have the union when I write the solution. So the first option is
X over 3 plus 6 is greater than 30. X over 3 plus 6 is less than negative 30.
do you all agree with these two?
Yes.
Okay. So then I move 6, and I get x over 3 greater than negative 3. And I multiply both sides by to get x greater than negative 9. Multiply both sides by 3, and I get this. Now the second one. I perform the exact same operation. I subtract 6, x over 3 less than negative 9. And from here, x is less than negative 27. Do you all agree with these two? And now I have to write the union. Please tell me, how do I write the union?
Negative 30, 27, negative 27, and then negative 9.
This is indeed the solution. Do you all agree? Yes? Questions? Okay, the next one I would like to work on is 48. Here is 48. The absolute value of 4x minus 3 divided by 5 less than 1. 1 minute. Can anyone tell us how to start this?
Negative 1 less than 4x minus 3 5 less than
Yes. So this inequality, first of all, is cleaned up. I don't have to do anything to the exterior of it. So now I know that when I'm looking for numbers whose distance from 0 is less than 1, they must be in between negative 1 and 1. First step towards solving for x.
multiplied by 5.
Do you all agree with multiplying by 5? What will be the next step, please? Very good. I'm adding 3. And the final step, divide by 4. Any questions? And in interval notation, x in the interval, which interval? If I don't write something in front of this, someone might say, oh, it's x comma y, but it's not. These are the values of x, anywhere between -1/2 and 2. Okay, I also want to look at 15 and 17. Any questions, please? And here's 17. You don't have to write both of them. I just want to move on from this page. 15. So 3x minus 7, everything over 4 in absolute value equals 2. Sorry about that. So the absolute value of 3x minus 7, everything over 4 equals 2.